So we're all living in the age of large language models, right? They can write, they can code, they can create. It's incredible. But the pace of AI innovation is just relentless. So today, we're asking a really important question. What comes after the LLMs that we know and use today? Let's dive in and take a look at the future that's literally being built as we speak.
It's so easy to look at a model like GPT-4 and just think, wow, this is it. We've peaked. It really does feel like magic sometimes. But is this really the final destination on the AI journey? Or are we just standing at a base camp looking up at an even bigger mountain, with today's tech being just one powerful milestone on the way to the summit? Well, the history of AI definitely suggests it's the latter.
Okay, so to really get a handle on where we're going, we've got to take a quick look back at how we even got here. The road to today's powerful models wasn't some straight shot. It was a series of major breakthroughs, and each one built on the last by, crucially, smashing through the limits of whatever came before it.
We started out with pretty simple, rule-based systems, what some people called good old-fashioned AI. But those proved to be way too rigid, so we shifted to machine learning, letting the machines actually learn from data. That then grew into deep networks, which could finally handle complex patterns in things like images and text, and most recently, of course, the transformer architecture unleashed the LLMs that are everywhere today. You see the pattern, right? Each leap happened because the old method hit a wall, and a totally new idea was needed to break through. And right now, transformers themselves are starting to show their own cracks.
Look, as mind-blowing as they are, today's LLMs are starting to bump up against some really fundamental limits. And these aren't just little bugs we can patch over. No, we're talking about deep, architectural challenges that are sparking a whole new generation of algorithms designed to leave them in the dust. So what are we up against? Well, it really boils down to 4 huge hurdles. First up, cost. The amount of compute, energy, and just cold, hard cash it takes to train and run these things is staggering. Second, context. The core engine of transformers gets exponentially more expensive and slow the more text you feed it, which makes analyzing, say, an entire book at once super inefficient. Third, reliability. We've all seen this, right? They can hallucinate or just confidently make stuff up. And finally, safety. Making sure these incredibly powerful systems can be controlled and governed, that is a monumental challenge.
But here's where it gets really exciting. For every single one of those limitations, brilliant researchers all over the world are cooking up new kinds of algorithms to solve them. This isn't just about making LLMs a little bit bigger. It's about fundamentally rethinking how AI can work from the ground up. Let's take a look at what's on the absolute cutting edge.
Okay, this slide right here really gets to the heart of the cost and context problem. On the left, you've got transformers and their quadratic cost. What that means is every piece of information has to be compared to every other piece. The complexity just balloons out of control. But now, look at the right. That's the goal: linear time. New architectures like state space models, nicknamed Mamba, work more like a clean, straight line. They process information one piece after another. This could mean handling millions of words of context, entire books, massive code bases, at a tiny fraction of the computational cost. This is an absolute game changer for efficiency.
The next huge leap is all about getting to genuine understanding. LLMs are fantastic mimics. They are brilliant at predicting the next most plausible word in a sentence, but they don't actually get the world. That's where world models come in. Their whole goal isn't to predict text, it's to predict how an environment is going to change. For example, instead of just describing a Jenga tower, a world model would learn the actual physics of it. It would understand that pulling a specific block from the bottom will probably cause the whole thing to fall. This could give AI a kind of real common sense, letting it plan and reason about actual consequences.
And this brings us to another really cool idea. We don't have to throw away the old approaches. Neurosymbolic AI is all about combining the best of both worlds. It takes neural networks, which are amazing at finding patterns in messy, real-world data, and merges them with symbolic systems, which are rock-solid at logic and structured rules. This hybrid could lead to AI that's not only powerful, but also more reliable, verifiable, and frankly, easier for us humans to understand.
So what's the point of all this? Well, these new algorithms aren't just academic exercises. They're paving the way for a future where AI is way more integrated into our lives, moving beyond being a simple Q&A tool to becoming a proactive, capable partner. This leads us right to the concept of agentic AI. Imagine you tell an AI, plan a weekend trip to Paris for me on a $500 budget. Instead of just spitting out ideas, an AI agent would actually break that goal down. It would plan the steps, Search for flights, find affordable hotels, check the reviews, and book the tickets. It would use tools like the web or various APIs to execute that plan all by itself, and then just present you with the completed itinerary. It becomes a doer, not just a talker.
And the future isn't just about these giant cloud-based agents. Remember those efficiency gains we were talking about? They also mean we'll see a lot more smaller, specialized models that can run directly on your phone or in your car. This is huge for privacy and accessibility. We're heading toward a world with personalized AI that adapts to you, becoming a true creative and analytical teammate, all while keeping your data local and secure.
So, as we wrap this up, the key takeaway is really this. The AI revolution is not over, not by a long shot. It's just getting started. The incredible tools we have today are simply the latest step in a long journey of innovation, and the challenges they present are the very things sparking the next wave of breakthroughs. Thank you so much for joining me. We really hope this has given you a clearer picture of what lies just beyond the horizon in the fascinating world of AI. We are Knowledge Equity Partners, a multilingual channel where we share contemporary and practical knowledge on a variety of topics that can enhance your daily lives and make them more effective and efficient. If you find our content valuable, please go ahead and subscribe to our channel, Knowledge Equity Partners. That way you'll get notified about our daily videos. And don't forget to like, share, and spread this practical knowledge with your family, friends, and your community.
Let's together keep the quest for knowledge always high.
The next chapter of AI is being written as we speak. What happens next is a story that's still unfolding, and we'll be right here to explore it with you. Be sure to look out for our next episode for more on this fascinating journey.